so we're going to go ahead and get started. As a reminder, can you tell which emoji is mine? Which one is mine?
Left. The one on the left.
The one on the left. Short hair.
And the other one is Miss.
The other one is
Miss Bowen.
Miss Bowen. All right, so yes, we combined Module 6 and Module 7. And then when we did that, we realized we made it Module 6, 7. So we realized we might as well embrace instead of fight it. So here we are, Module 6, 7. So it is all about multiplying and dividing integers and rational numbers, and there's a lot that goes into that you need a refresher on. So our goal today is to understand, explain, and be able to simplify expressions that involve exponents, that involve order of operations, and the use of the distributive property. So when I say an exponent, there's two parts of an exponent. There's the base and the exponent itself. Okay? When you taught my cheer folks, okay, your base in cheer is where?
Bottom.
On the bottom, right? And it's holding up the flyer, correct? Same thing here with your exponents. The base is the number on the bottom holding up the exponent. Okay, so your base is the bottom big number. Number. Okay? It is the number being multiplied. Your exponent then is the little top number, and it tells you what? Does anybody remember what the exponent tells you? How many times you're going to multiply it, or how many factors they're going to be. How many times are you going to multiply the base? So we've got an example of 9 to the 0 power here. Which one's the base and which one's the exponent?
9 is the base and the 0 is the exponent.
There's the base. There's the exponent. Exponent's the little flyer. It's the little Haley in the situation. I don't know who's a base in cheer, but alright. And Sophie's our base. Alright. Going way back to like 3rd grade.
Oh God, I don't remember.
Oh no, we can't remember
That
that.
grade was a hard time. Yeah.
Alright.
That was my worst.
So, what if, because you talked about it in 3rd, 4th, 5th, and 6th. And 7 now. Okay. What is a factor? It is a number.
That's a number. Something that you put on. Like.
Alright, do you remember GCF? Greatest common factor?
GCF and LCM.
Alright, GCF and LCM, but the factors
Are just different numbers, a range of numbers.
the numbers that multiply together to give you a product. So like if I had 12 and I wanted to list all the numbers that multiply to give me 12, what are the different ways I can multiply to get 12?
6 times 2.
6 and 2.
3 times 4.
3 and 4. 12 times 1.
Times 2.
Okay? So all those that you just listed are the factors. So factors are the numbers you multiply to get a product. And product is what?
The answer to a multiplication problem.
Answer to a multiplication problem. So if I had an example, if I had 3 times 4 equals 12, 3 and 4 would be your
Factors.
factors. Alright, what is orders of operation?
Oh, I totally forgot.
Oh, the multiplication.
It's PEMDAS, which is,
Parentheses.
or y'all do, please excuse my dear Aunt Sally. Y'all still do that?
That's the only part I
Multiplication.
Yeah.
Multiply, divide,
Add and subtract.
Parentheses, exponents, multiply, divide, add, and subtract.
Go left to right.
And you go left to right. It is the order in which you should live math. You always follow order of operations for all math purposes. You always go in that order. It's the order in which we do math. Math works because there's an order to it. There's rules to it. Okay?
My favorite thing.
Your scientific calculators will do order of operations for you, but because you've only used scientific calculators, you have forgotten the order. And what's going to happen starting this year and next year and in high school, numbers are going to go away and letters are going to come in.
No.
And you're still going to have to be able to work the problem. And guess what? Those beautiful scientific calculators only do numbers, not letters.
They do letters.
They do letters, but they do not do order of operations with letters.
My dad has a calculator.
Dun, dun, dun. So, you've got to know how to work it. All right, distributive property. Anybody remember about distributive property? What it looks like? Ooh, Lordy. If I have 3 parentheses x minus 4. Does anybody remember seeing something like this?
Last year, at the beginning of the year.
And then you give the 3 here and the 3 there.
Oh yeah, I do remember.
Y'all did this last year.
I do.
Okay? This is why we're reviewing, because you don't remember. Because you just put it in the calculator. Okay? So, that's what we're reviewing today. We've got to review all that in 30 minutes. So, here we go. When you have an exponent, it's important that you read it correctly. Okay? How would I read this expression here? Right? 9 to the power of 0. Or you could read it as 9 to the 0 power. Either way is read correctly. Now this one's difficult because the exponent tells me how many times I'm going to multiply it. How many times am I going to multiply 9? 0 times. So you can't really write this out. This 9 to the 0 power is very special. Anything to the 0 power is what?
0.
It's
That's something you need to know. Anything to the 0 power is 1. And I was looking for a good video to explain that why. I haven't found it yet. But when I do, we'll look at it. Alright, so how would you read this number?
5 to the power of 1.
Alright, 5 to the power of 1. Or 5 to the first power. Either way. How do we write this? How many times are we multiplying it?
5 times 1, which is once. Wait, once. So 5 times
We're doing 5
1 time.
one time,
So,
which simplifies to just 5. Alright? This one can be read a couple different ways. When you have a power of 2, you could read this as 4 to the second power, but does anybody know when we have an exponent of 2 what it's called?
square.
Squared. Anytime you have a 2, you'll see it as called squared. So if you had a square, it would be a 4 by 4 square. Because you're doing 4 how many times? Twice. So 4 by 4. So we would read this as 4 squared. It would be written as what? As a multiplication problem, how would you write this?
4 times 4.
Not 4 times 2, but 4 times. That's the biggest, I'm glad you said that, because that's the biggest misconception that a lot of people do. A lot of people go, that is 4 times 2. If that was 4 times 2, we would write 4 times 2. This is 4 2 times, written 2 times. And 4 times 4 is 16. Alright. When we have a 3 has a special name. Cubed. A 3D square is a cube. It's 3-dimensional. This is we call it cubed. So we would write it or read it as 7 cubed. Now you could still say 7 to the 3rd power. Or, if you want to be more advanced, you say 7 cubed. How would you write this one?
7 times 7 times
7 written 3 times. 7 times 7 times 7. This is how many factors of 7 we should have. So in your fancy little calculators y'all have, you do 7 times 7 times 7. And it simplifies to a result of
343.
343. Seven times 7 times 7. Okay. All right, next. All right. What's the special word for 4?
squares.
No, we just need
It doesn't have one. It doesn't have one. 2 and 3 are the only ones that have special names. Everything else, you would just read this as 2 to the 4th, or to the power of 4, to the 4th power. How would we write this?
2 times 2 times 2 times 2.
All right, 2 written 4 times. So 2 times 2 times 2 times 2. This is not 8. Everybody almost always falls for the trap for some reason when it's 2 times 4.
16.
It's not 8, it is 16. Because if you do 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. Okay. Does it kind of remind us how exponents work? Yes, no? I think so. What if we had x to the 3rd power? How would you write that? X to the power of 3, and how would you expand it out? Or x cubed?
X times 3. No, X times X times X.
It would be x times x times x. which cannot be put into your calculator, correct? Nope. Alright. So, please excuse my dear Aunt Sally. I don't know if y'all ever heard that saying, but that's old school way. That's how I learned it. And then they came up with the whole PEMDAS situation, okay? Parentheses really stands for any grouping symbols. Okay, sometimes they're brackets, sometimes they're parentheses, and then there's parentheses within parentheses within parentheses. It gets real elaborate sometimes. But within parentheses, or any of your grouping symbols, you follow order of operations. So you do it first, and then you follow order of operations from within it. Then you do exponents. Then you multiply or divide from left to right, whichever comes first. So when you're reading it, if division comes first, you do division first. Multiplication comes first, you do multiplication first. Same thing for addition and subtraction. From left to right, whichever comes first. Okay? So what I like to do is I like to make like a little checklist. Oh, something happened with this right here. Let's make this a 3 right here. I don't know why that got cut off, but make that a little 3 right there. Alright, so we want to simplify this expression. But what I do is I like to write my order. I like to write PEMDAS this way. Did y'all have to write PEMDAS like that last year?
Yes.
Okay. Well, if you didn't, this is how we write it. We stack it on top like this, and then we go through. Do I have any parentheses?
No.
No. Do I have any exponents?
No.
No. Do I have any... Go away. Do I have any multiplication or division?
Yes.
Yes. So when I read it, what comes first?
Multiplication.
Multiplication. So 4 times 2 is 8. Okay, and then I can keep on going down the line. Do I have any more?
Yes. 4 times
4 times 3, which is
12.
And then you bring everything else down. And then it should start to funnel kind of like a pizza slice, right? Do I have any more multiplication or division? Nope, so I'm done there. Do I have any addition or subtraction?
Yes.
Yeah, so I work from left to right. So I do 5 plus 8.
13.
Then I bring my stuff down. Then I do 13 plus 10, which is
23.
and minus 12.
11.
11. So my answer is...
Dorito chip.
It does look like a Dorito chip. But what the question is, which Dorito is more superior? The blue ones or the red ones?
Blue ones.
Blue one.
I like
sweet
before I like chip.
The purple.
It depends on what day I'm having.
If it's a good day.
I don't know. I really like the blue Doritos, the
Yeah.
Cool Ranch, but I also can go hard on the red Doritos too.
I ate a whole
I don't like
this
those.
giant family pack of the red Doritos. I ate a whole bag by myself.
All right, so all right, let's move on. Let's make another Dorito chip over here. Please excuse my dear Aunt Sally. What's going to be our first move?
Multiplication or division.
Right, because we don't have any parentheses, we don't have any exponents. But I do have some multiplication. 2 times 4 is 8. Then I bring everything else down. Then what do I do first?
Addition or subtraction.
So,
Addition, because it comes first.
12 plus 10, because that comes first. So I got 22. Then bring everything else down.
Addition again.
Addition again, which gives me 30. Minus 1, which gives me 29. And then there's your another Dorito.
Our teacher last year, my teacher last year made us draw
Sweet chili.
the We called it a pizza, and she made us show it, and if we didn't show it, she wouldn't give us a point.
All right, this one. Where do we start?
Parentheses.
Do we have parentheses here? So, all right, we've got to follow order of operations within the parentheses. Do I have parentheses within the parentheses? Do I have exponents?
Yes.
So I have to do that. So it is 4 times 4 plus 8 is how that would expand out. We got to do that first. So 4 times 4 is 16 plus 8 gives me 24. So I'm now done with the parentheses, and I can bring everything else down. Divide by 2 plus 9. Do I have any more exponents? No. Do I have any multiplication or division?
Division.
Yes.
Division. So 24 divided by 2 is
12.
plus 9. 21. 21. You're too young to remember that.
No,
It's a little wonky, but very long Dorito chip. Okay? Alright, we refreshing our brains? Kinda? Okay? You try. You try. As my nephew would say, I try. Try. Alright, try those 3. Follow your steps. gonna work it up here while y'all work it down there. Alright. That's what I got. One of the things that you need to remember is that, especially this problem, this last problem right here, when it's in parentheses, it's like saying this whole group is its own little problem being inserted into the problem. You're almost like two separate problems, and then you're combining it with whatever operations in between. Okay? How many of you the exponents messed you up? Be honest. Yeah. Y'all gotta be careful with those exponents. They'll get you every time. This is not 2 times 3. It's 2 times 2, which is 4, times 2 again, which is 8. You need to start memorizing some of those. You need to know 2 to the 3rd power and things like that. Alright, we're going to keep on rolling because this is kind of a review. We're not going to do number 7. That might be like our warm-up question tomorrow or something like that. Seeing if you can identify where they went wrong. But we are going to look at the distributive property since a lot of you did not remember what distributive property is. So we're going to go over it, and then we're going to do a quick little hands-on demonstration with our algebra tiles before you jump into your homework tonight. But to distribute, I distributed your papers and your algebra tiles. It means to give evenly. To give evenly. If I was passing out candy and I skipped a whole table, y'all, a whole little family, y'all be like, "That's not fair. You didn't give us candy." Okay? So you want to give evenly, you want to distribute. So what it is you are giving the number or variable on the outside of the parentheses to both, or however many numbers are on the inside of the parentheses. So an example could be like 5, 6 plus 3. Okay? That could be like an example when we're going to see some of that. You're going to give that 5 to the 6 and to the 3. Does anybody remember what operation the giving represents? When you give the 5 to the 6, what operation are you doing to it? You're doing multiplication. Giving is multiplication. Okay? And what we're going to do is we're going to model this with your algebra tiles. Okay? So that's what we're going to do.